Project oVERFLOw is co-funded by European Commission through the European Union Civil Protection Mechanism. Project has developed innovative tools and procedures for civil protection agencies and infrastructure managers to improve their decision-making regarding the preparedness and prevention of flooding hazards. Consortium consists of 7 partners coming from Croatia, Slovenia and Netherlands, which are coming from universities, research institutes, SMEs, civil protection agencies, with very strong support of infrastructure managers. In recent years, Europe has experienced severe flooding hazards with many casualties and infrastructure failures, and therefore it is of crucial importance to assess the vulnerability of our critical infrastructure such as bridges and flood protection systems.
The main outputs of the oVERFLOw project are applied and validated in 2 case study areas. One is in the Netherlands near city of Dordrecht and the other one is in Croatia, city of Karlovac. Both are extremely prone to flooding hazard. During the project we have applied innovative technologies for vulnerability assessment of bridges and embankments, which included remote sensing and different non-destructive techniques. And finally, they are used for the risk assessment for different flood scenarios in those selected areas. The final output is a risk forecasting tool, which is quantifying direct and indirect consequences of flooding in those selected areas. Based on that, we are developing a set of guidelines for integration of the developed methodologies and tools for civil protection agencies and infrastructure managers.
In this project, we had 2 interesting case studies, and one of case study is standing right here. This is the Banja Bridge, steel bridge, which was here within this project thoroughly analyzed. We actually included several flooding scenarios, and with that in mind, that local scarring, that means the flashing of the riverbed, can cause the stability issues of the bridge. So what we have done here is we use drones and sonars to gather several data about the bridges and the riverbed, and we use this data to analyze the response of the bridge in case of the floods. Additionally, we put accelerometers on the bridge where we measured moat periods and moat shapes of the structure, and we considered this data in our analysis to have more realistic behavior of the bridge. We actually were here really interested in the local scour, which is actually one of the main reasons for the bridges in the world to collapse. And the idea within this project was how can we combine different flooding scenarios in our analysis and tell the municipalities or CPAs, that is civil protection agencies, how should they respond to these different scenarios.
The area of the safety region South Holland South is prone to flooding. It has its influence from sea and discharges of the rivers. The area has a high level of urbanization, industry, and is an infrastructural hub for the port of Rotterdam, all below sea level. The vulnerability assessment of the Oostmolendijk is of high importance to the Waterboard Hollandse Delta. For the safety region South Holland South and its municipalities, the oVERFLOw risk assessment helps us to improve our preparation and response plans when a flooding might occur.
For the purpose of the oVERFLOw project, we used remote sensing methods which involved drones. Drones gathered aerial photos which produced 3D point cloud of the scanned area. From 3D point cloud, which were produced from aerial photos, embankment geometry was produced and involved in further analysis for embankment flood protection.
Mi u gradu Karlovcu vrlo smo zadovoljni što smo baš mi izabrani da budemo unutar ovog pilot projekta, zbog toga što se nalazimo na 4 rijeke gdje su velike problemi sa poplavama i tako su i posljedice znaju biti dosta velike. Rezultati unutar ovog projekta puno će pomoći prilikom procjene rizika kod budućih poplava, pa se tako nadamo da ćemo sudjelovati u nekim daljnjim projektima.